All right, in college algebra lesson 2.3 on functions. We're going to talk about if a relation is a function. So for that to be true, remember all the x's would have to be different to be a function or a graph past the vertical line test. The domain, a lot of you will say that's the x coordinates. The range is the y's. And then function notation, that's just the f of x equals. And increasing, decreasing, and constant is a new concept to you guys from Algebra 2 to college algebra. So this first part was review. Decide whether the relation is a function. So again, you're going to ask yourself, are the x coordinates all different? If you answer yes, then yes, it's a function. If you say no, then it's not a function. So are the x's all different? Hopefully you said yes. Therefore, this is a function. Right? Is in a function. I'm looking at the x's, 2, 3, 4, and 5 are all different. Therefore, it is a function. And this one, again, look at the x values. Is it a function or not? It is not, because the x's are not all different. I have -4's that repeat, so this would not be a function. All right, domain and range, and is the relation a function? So first off, are my x's all different? The answer is yes, so it is a function. The domain, most of you will say that's your x values. So the domain would be the -4, -1, 1, and 3. The range would be your y values, -2, 0, 2, and 5. And all those x's were different, so it was a function. All right, domain and range again. So what's the domain? I want you thinking, is the domain the blue numbers or the red numbers there? See, my domain is the blue numbers. That's the x's. See, this is the point 1, 4, the point 2, 5, 2, 6, 3, 7. So my domain would be 1, 2, and 3. My range, that would be the red ones, 4, 5, 6, and 7. Notice I did not repeat the 2. Now, is it a function? And hopefully most of you are saying, no, it's not, because this 2 was repeated. This is the point 2, 5 and 2, 6. So all the x's are not different. This is not a function. All right, again, what's the domain? Most of you say that's your x values. That's the independent variable. That would be these values here. My range. See, would you put 5, 5, 5, 5 for the range? Or would you put just 5? Hopefully you said just 5. That would be the correct answer. Now, is it a function? See, ask yourself, are the x values all different in this table of points? And yes, they are, so yes, it's a function. All right, determine the domain and range again, and is it a function again? So the domain is our x values. So looking at these points, -2, 3, -2, 0, 4, 0, 4, 3. So my x values only take on the value of -2 and 4. That would be my domain. My range would be the y value, so that's 3 and 0. Is it a function? Hopefully most of you said no. The x is repeated. See, all the x's are not different. You have to ask yourself, are all the x values different? No, so it's not a function. All right, this time the domain. How far left and right does the graph go? So I like using this little statement here, domain and range. This way to remind you, domain's right and left, range is the up and down. So how far left does our graph go and how far right? Now this 5 is representing that point. This actually goes out here to 6 on the graph. So my domain, how far left to -5, how far right to +5, and inclusive. So those would be with brackets. Your range, how low does the graph go to how high? So my range would be from -3 to 3. Is it a function? See, remember, ask yourself, are the x values all different? Hopefully your answer is no, they're not all different. Therefore, this is not a function. So this section here, it's really important that you understand these basic graphs. I highly suggest for this slide and the next 2 slides that you put this equation on the front of a flashcard with this information, and then fill out this information on the back of the flashcard along with the graph. It's very important that you do that because we're going to apply this to equations that are more complicated. So first off, y equals x. I hope most of you know that as a parent function as a line. Starts at 0, slope is up 1, right 1, up 1, right 1. The name of it is a linear function. The domain, how far left does it go and how far right? Well, it goes left forever and right forever, so that would be -infinity to infinity. And I would advise you when you start this homework assignment to copy that using Control-C, and then later when you need to keep reusing it, use Control-V for paste. It'll help save you some time. All right, the range, how low and how high. So again, that's another all real numbers, -infinity to infinity. All right, the equation y equals x squared. Pause the video, try to make a graph of it, and then see if you're right in just a second. Hopefully you knew that was the graph of a parabola. See, if I take 0 and square it, I get 0. 1 squared is 1. Negative 1 squared is also 1. And therefore, that would be the graph of my parabola. The name of this is a quadratic graph. The domain, it goes left and right forever, so it's still all reals. The range this time, though, see how low does this graph go? See, the graph starts at 0 and goes up forever, and so that's why it would be from 0 to infinity with a bracket. All right, y equals x to the third. Pause your video, try to make this graph. So y equals x to the third, you should have done this. See, 0 to the third, 1 to the third is 1, negative 1 to the third is negative 1. 2 cubed is 8. Negative 2 cubed is negative 8. This is what the graph would look like. The name of that is cubic. It does go left and right forever, so again, that's all reals. Range, how low and how high? Well, down forever, up forever, so again, all reals. All right, the graph of y equals the absolute value of x. Pause your video, try to make that graph. All right, so y equals the absolute value of x should have been a V-shaped graph looking like this. See, the absolute value of 0 is 0. The absolute value of 1 is 1. Absolute value of negative 1 is also positive 1. And this is what the graph would look like. The name of it is just absolute value. Domain, how far left and right? All real numbers. Range, though. See, it doesn't go down forever. It actually starts at a lowest value of 0 and goes up forever. Now, it includes the 0. So hopefully you're thinking, well, then that 0 would have a bracket. That is correct. Up forever, infinities always have parentheses. 2 more graphs. So y equals the square root of x. So again, pause your video, try to make the graph. All right, so square root of x. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. Square root of negative 1 is imaginary. Square root of negative 4 is imaginary, so I don't have any graph over here. The graph of that was this here. The name of it's square root. The domain, where do those x's start at? See, they start at 0 and go right forever. It includes the 0. And what about your range? How low does this graph go? And how high? So again, how low? Well, it starts at 0, inclusive, and up to infinity forever. All right, one more time, pause your video. Try the graph of y equals the cube root of x. All right, the cube root of x, we should have done the cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 would be 2. Then the cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. So this is what the graph looks like. The name of it is cube root. Again, how far left and right? All real numbers again. The range, down forever, up forever. Again, all real numbers. Now, it's going to be very important that you guys memorize these graphs because anytime we have a square root, fourth root, sixth root, eighth root graph, it's going to look like this. Anytime I have a third root, fifth root, seventh root, 11th root, any odd root, it will look like this. So if you know these basic parent graphs, then you're going to be able to answer in your homework the domain and range very simply. I'm not sure if that's the correct grammar on that words. All right, so this question wants to know, is this relation a function and what's its domain and range? So we need to think about what the graph looks like. See, this is a graph of a what type of function? I hope most of you think it's a linear function. It graphs a line. So it starts at negative 5 on the y-axis. This slope is up 2 and right 1, up 2 and right 1. That is a function because every x value along this line is different. The domain, it goes left forever, right forever, so it's all reals again. The range goes down forever, up forever, so the range again is all real numbers. So this function, y equals x squared plus 3, or is it a function actually, I should be asking. So it's a relation right now. So y equals x squared. A minute ago, we graphed that. That was a parabola opening up, starting at 0, 0. But what if I have it as y equals x squared plus 3? What happens with that plus 3 on that parabola? Hopefully you're thinking that's going to shift it up 3 because that is correct. That would be a vertical shift of 3. Now, are all the x values different? Yes. As I move along this curve, every x value keeps changing. The domain, how far left and right? All reals again. But my range, where does this y value start at and then continue to go? So it starts at 3 and goes up forever. So it would be a bracket on the 3 and infinity with a parenthesis. All right, we're going to pause the notes and I'll move on to part 2. So be just a minute and we'll continue.